Hi everyone and welcome to Maths Revision with Jov. Today we're actually going to be looking at an A-level problem. However, the techniques used to solve it are no higher than GCSE level. I'll show you why in a minute. But the question reads, determine the set of values of k such that the equation x squared plus 4x plus k plus 3 equals 0 has two distinct real roots. First things first, we need to make sense of what the question's asking us. So it's asking us to check out this equation, x squared plus 4x plus k plus 3 equals 0. That's a quadratic equation. We know that quadratics always have at most two roots. They can be real or not, but for the sake of this problem, they are going to be real. And we want to show what values of k in this equation give us the result that the equation has two distinct real roots, which means they're both real and they're different, they're distinct. So in a quadratic equation, when you plot the graph of it, you'll get something like that, where it crosses at 2 points. And this is the type of graph that we're looking for. Sometimes you get equations which, when plotted, look like this. And this doesn't cross the x-axis anywhere, which means it doesn't have any roots, or doesn't have any real roots, you would say. To solve this, we're going to have a look at the quadratic equation, which says that for any quadratic equation that ax squared plus bx plus c equals 0, we have that x is always equal to minus b plus or minus the square root, because square roots are plus or minus, of b squared minus 4 times a times c divided by 2a. This should be familiar to you, especially if you're doing the higher paper. But this is the quadratic formula. It determines both solutions of any quadratic equation. If we have a quick think about what's going on in this equation, we actually see that we have a square root over here. Now, in order for a square root to give us a real number, what's inside the square root must not be negative, because if we have a negative, for example, square root of -1, this is actually not possible to solve using real numbers, because there is no number that when multiplied by itself gives us a negative number. So we get no solution in the reals for that one. What we can actually do is we can take just this square root and what's inside the square root. So the square root of b squared minus 4ac. And this is called the discriminant of the quadratic formula. So when you see this is called the discriminant. Just remember that as terminology. And in order to produce two distinct real roots, this needs to be greater than or equal to 0. However, if we have that this is equal to 0, we just get b plus or minus 0 over 2a, which gives us just one solution, so it's like a repeated root. So what we want to do is we want to make sure this is not equal to 0. So we're going to simply greater than 0. Since we've got the inequality of the square root of b squared minus 4ac being greater than 0, we can actually just square both sides, and it's really simple. So we just want what's inside this square root to be greater than 0. But now we can go and substitute our numbers in from the question. So we get b squared, well b is just 4, there's 4 over here in front of the x. So 4 squared minus 4 times, well a is just what's in front of the x squared, so 1. So 4 times 1. And then c is this k plus 3 over here, which is our constant term. There are no x's involved there. And this is going to be all greater than 0. We can go ahead and expand, so we can simplify this a little bit. So we get 16 minus 4 times k plus 3, well 4 times k plus 3 is just 4k plus 12, but this is all minus, so it's got minus 4k minus 12, and this is greater than 0, which means we've got 16 and then minus 12 over here, so 4 minus 4k is greater than 0. We can actually divide by 4 here if you want it. You don't have to, you can simply just move the 4k onto the other side, but for the sake of looking nice, we will divide by 4, so we get 1 minus k is greater than 0. Now we can just add k to both sides. So we get that 1 is greater than k, or k is less than 1. And that is our final answer, and I hope that helps.